Okay, in this video we are continuing our review of Unit 8, Sequences and Series, and we're going to go ahead and pick up by talking about how to find finite sums. Remember, finite sums are every single sum that we covered up until the last day when I mentioned that there are also infinite sums, and infinite sums have their own formula. So every formula we learned, S sub n, every other S formula we learned was a finite sum. So let's go ahead and take a look at these equations and see if we can figure out how to find their sums. So starting with question A, this is in sigma notation. It's asking me to find the sum of all of the terms of the equation 2n plus 5 from n equals 1 to 50. So if we want to figure out how to find the sum of this formula, we're going to have to figure out what type of formula it is, because we have different equations based on if it's geometric or arithmetic. In this case, I can tell because I have some information about sequences. I've memorized these two formulas, dn plus, a sub 0, thank you very much. I know that this is the arithmetic standard form, and geometric is a sub n equals a sub 1 times r to the n minus 1 power. Because I know these two standard forms, I can tell immediately that this equation in problem A is arithmetic. I can see that d is the number 2 and a sub 0 is the number 5. I can tell what all the terms are based on my knowledge of the general equation. So since this is arithmetic, I'm going to need to use one of the arithmetic sum formulas. And I will provide these to you on the test, but there are two to choose from. One of them uses a sub n, and one of them uses d. And I could honestly use either one of those two equations that are provided to you, except that I would rather not use the formula that's got d in it because it's longer and it's just a little bit more obnoxious to plug things into. So I'm going to go ahead and take the arithmetic sequence formula that uses a sub n. And that formula is the sum up until the nth term is n times the first term plus the last term, all divided by 2. And that formula will be given to you. It will be called the arithmetic series formula, and you're going to see that it has a sub n and a sub 1 in it. So if I want to plug things into this formula, I need some information. I need n, so it's the sum up until the nth term, and I can find that in my sigma notation problem right here. N is going to be the last term I care about, which is the number 50, the 50th term. I'm also going to need a sub 1. A sub 1 should be the first term, and in the sigma problem, to find the first term, I plug in the number 1. So I'm going to have to do 2 times 1 plus 5 to find the first term. So it's 2 plus 5, which is 7. The last thing I need is a sub n. Now a sub n is a sub 50 in this case, so I'm going to have to plug in 50 to find my last term. So 2 times 50 plus 5, which is 105. So now I know my first term, I know my last term, and I know n. I have everything I need to plug things into this formula. So to find the sum up to the nth term, all I have to do is add together my first term, 7, and my last term, 105, and then divide by 2. Oh, and multiply by n. I forgot to multiply by n right here. Sorry, n should be in there. There should be a 50. Ha ha ha, I have the formula right here. N gets multiplied in front. Sorry. Okay, so now that I have my formula ready, let's go ahead and simplify. So the sum up until the 50th term is 50 times 112 divided by 2. And if we plug that in the calculator, we get 2,800. There we go. For the next problem, I have to, again, figure out what type of formula I'm going to use before I can start calculating. So I have to figure out the formula by finding my pattern. If my pattern is adding or subtracting, I know it's arithmetic and I already know the formula I can use. If my formula is multiplication, then I know it's geometric, and I'm going to have to use the geometric series formula. So in this problem, to get from 1/8 to 1/4, it's pretty tricky to figure out what I would have to add or subtract there. I don't have common denominators, so adding and subtracting would be complicated. I have a feeling it's probably a ratio, because I know that 8, 4, and 2 are all tied together by dividing by 2. So let's go ahead and find r. Using the technique that we discussed in class, I'm going to take a term and divide it by the one that came before. So I'm going to do 1/4 divided by 1/8. And if we do that in our calculators, we get the number 2. To make sure that it's a pattern, let's go ahead and check the next one, 1/2 divided by 1/4, see if it's the same pattern. If it is, then we have r. And in the calculator, it's the number 2. So we know r equals 2, and we also know this is geometric, which means I'm going to need the geometric series formula. The geometric series formula, there's only one of them to choose from, and the formula is S sub n. There we go. S sub n is going to equal the first term times 1 minus r to the nth power divided by 1 minus r. So let's go ahead and see what we have to plug in. We have to plug in r, and we found r, so that's going to be all right. We have to plug in the first term, and the first term is right here, 1/8. We also have to know how far we're going. We need the n, and it looks like we're trying to find the sum up until the 10th term, so we're trying to find n equals 10. So n equals 10, and for clarity, a sub 1 is the first term, 1/8, which means we have everything we need to plug in here. So we're doing the sum all the way up until the 10th term, and it's going to equal our first term, which is 1/8, times 1 minus r, which is the number 2, to the nth power. So that's the 10th power. And then in our denominator, we're going to have to do 1 minus r. r is the number 2. So I recommend you plug that straight into your calculator. If you simplify it piece by piece first, that's okay. Just leaves a little bit of room for error. But when you are finished simplifying, we will get that the sum up to the 10th term equals 127.875. If you left it as a fraction, that is totally fine. It's completely acceptable. If you want to see if they're equal, go ahead and type in the fraction that you got and hit the side-to-side arrow button to see if it matches the decimal that I got right here. All right. Let's go ahead and check question C. Again, we're going to have to figure out what our pattern is so we can figure out what equation to use. To get from 2 to 6, I can add 4, and I can actually do the same thing the whole time. I can keep adding 4. So it looks like this is arithmetic, and we have a d value of 4. And that means that I'm going to have to use one of the arithmetic equations. One of them is the one I wrote down up here. This is the arithmetic equation that we have so far. And in order to use it, I need to have the first term and the last term, the values of the first term and the last term. Down here, I have the first term, 2, but I don't have the last term. What I do have, however, is this d value, which means I get to make a choice. I can either use this information to calculate the value of the last term, or I can go ahead and just concede to use the formula that has d in it. And even though it's a little bit more obnoxious to plug things into, it's still just one formula to use, and it's a little easier than using an additional formula to find another term. So it actually might be easier just to go ahead and use that other arithmetic formula, the one with d in it. Let's go ahead and write that formula. S sub n equals n times 2a sub 1 plus n minus 1 times d divided by here we go, 2. So this is the other arithmetic formula. And again, this will be on the reference sheet. You don't have to memorize this, but it's kind of an inconvenient one to use unless we have to. So in this case, since we only know d and we know a sub 1, this is the best one to use. The only other thing that I would need to know besides d and a sub 1 is I would have to know the n value. So let's go ahead and calculate n. We don't actually have to do much work. N is the very last term that we care about, and it says to find the s up to the 20th term. There's that n right there, so n equals the number 20. So it looks like we're going to be ready to go. We're going to find the sum up to the 20th term, and it's going to be 20 times 2 times the first term. The first term's the number 2, plus n minus 1, so that's 20 minus 1 times d. d is the number 4 in this case. So we have that guy already, and the denominator is just the number 2. If you want to simplify this yourself a little bit before you type in the calculator, you can, or you can just type that entire thing in the calculator. Either way, you should get that the sum up to the 20th term is 800. Now we just have one more problem to solve. The last problem to solve is given to us as an equation, and again, at the very beginning, I wrote down the formulas for the two equations. Here is the arithmetic equation, and here's the geometric. It looks like the very last problem matches this format. This is a geometric equation, and because it's in geometric form, I can see that this term, -3, is a sub 1, because that's the position that it's in. I can see that this number 2 is r, because that's the position that it's in. And I can see, because we're going up to the 32nd term, that number 32 is going to be the number n. So I'm going to have everything I need to use my geometric formula. Remember, there's only one of those, and I wrote it down right over here. This is our geometric formula. It's the only one we've got. Again, it will be provided to you on the reference sheet. So we're going to go ahead and use that again right down here. So we're going to do s sub n equals a sub 1 times 1 minus r to the nth power divided by 1 minus r. So let's go ahead and plug in the information that we've got from this problem. I'm going to go ahead and switch r over to red since I accidentally just used blue. So we're going to plug in s sub 32 equals the first term, which is -3, times 1 minus the r value, which is 2, to the nth power, which is 32nd power. And our denominator is 1 minus the r value, which is 2. So we have everything plugged in that we need. This answer is nasty, but it doesn't matter because we get to plug it in the calculator, and our final answer, once all of that has been calculated by our wonderful piece of technology, is -1.2884901, etc., 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 times 10 to the 10th power. Times 10 to the 10th power means that this decimal place can be moved over 10 times. I used a fancier calculator to find the answer to this, and it gave me -12,884,901,888, which, if you notice, if you move this over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can see it matches up all of the digits except for these last 3 8s, because your calculator, the scientific calculators in class, just ran out of room to solve this problem. Don't worry too much about this disgusting answer. There won't be anything this nasty on the test, and this would be completely acceptable if you wrote it down on a piece of paper. Just write down what your calculator tells you. If it scares you, write down exactly what you see. All right. We're going to move on to finding some other missing terms in the next video. We'll pick up with question 8 coming up here in just a second.